Okay, let's talk about if you have a coordinate that's not on the unit circle. So that's saying then your radius is not 1. So I'm going to create a circle, not the best. And then here you have your radius. And because I know I'm going to create a triangle, I'm going to make it look like that. Well, then I'm going to make my radius, I don't know, 8. I'm still going to make this 30 degrees. So then I know this length over here has to be 4 because it's half of your hypotenuse, and your long leg has to be 4 root 3. Well, if I'm going to assume that my center of the circle is at 0, 0, that means this coordinate is 4 root 3, 4. But I'm confused because sine of 30 degrees is not 4, and cosine of 30 degrees is not 4 root 3, according to my unit circle. So that's why I'm going to go ahead and find sine of 30 degrees. Well, that is opposite over hypotenuse. And we do get 1/2, which when you look at your unit circle, sine of 30 degrees is 1/2. And then cosine of 30 degrees is adjacent over hypotenuse. Reduce these guys, so you get root 3 over 2. So they do produce the same thing. But what is different is this is no longer just my y value, and this is no longer just my x value. So you can't assume that because you're no longer dividing by 1. So that's a huge thing. It's 30 degrees, sine of 30 degrees will always be 1/2, but it's not going to always be your y value. And cosine of 30 degrees is always root 3 of 2, but it's not always going to be your x value. So when you're not in the unit circle, we have these nice formulas, which you can memorize if you like. I'm not someone that likes to memorize a bunch of different things, so I'm going to show you 2 different methods of solving for when you're not on the unit circle. But let's compare this. So this formula is saying, well, if you're not on the unit circle, I should have a formula that says x equals r times cosine of theta. And to be clear, this would work on the unit circle because your r would just be 1, so you get cosine theta still. But for us, my radius is 8 cosine 30 degrees. And I end up getting cosine of 30. That I know, looking at my unit circle, is root 3 over 2. So I get 8 root 3 over 2. So then I end up getting, that reduces 4 root 3. And what do you know? We got the same thing. It also says, well, then your y value is r times sine of 30, which is 1/2. So we get 4. So we get the same thing. For me, I like just creating a triangle and doing the Pythagorean theorem and solving for it. So going down here, we're going to put this to use. This is generalizing things we just discussed. So you're given some coordinate, but you know you're not on the unit circle, okay? Or you could be on the unit circle. Actually, this works true for all unit circle as well. But this is especially helpful when you're not on the unit circle. This is just Pythagorean theorem because r is your hypotenuse. And this is just the definition of sine, definition of cosine, definition of tangent, and so forth. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So if you need a visual, this is your x, this is your y, that's your r. And so when you stand here, your sine would be opposite over hypotenuse, and so forth. So let's see. Example 2. Find the exact value of the 6 trig functions of an angle if theta has negative 1, 2 on its terminal side. So if you're in the xy plane, negative 1, 2, there's your coordinate. And it's saying you have this angle that starts initial side. The terminal side goes through it. So it's saying that you have this angle. But I need to use my reference angle to figure this out. So I'm going to make a triangle here and use this reference angle. And I know that this value is negative 1, and the negative is just talking about direction. And then I went up 2. But what I don't know is my r. Okay? Well, I'm going to do Pythagorean theorem. So I get 1 plus 4. So I get 5. So r equals root 5. So I'm going to put root 5 there. And so now I have all my missing lengths of the triangle. So finding sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, because these are your 6 trig functions, cotangent of theta, is just going to be taking the ratios from the triangle. So sine is opposite over hypotenuse. Can't leave it like that, so I have to rationalize. Cosine of theta would be adjacent over hypotenuse. Can't leave it like that, have to rationalize. And you can put this negative anywhere as long as just the ratio is negative. Tangent is opposite over adjacent, which would just reduce to negative 2. And then finding the reciprocals, this is going to be easier to flip. So I'm going to flip that one. So that's root 5 over 2. Secant is this reciprocal, which is negative root 5. And cotangent's reciprocal of tangent is negative 1/2. And again, you can see cosine's value does not match the x value. Sine's value does not match the y value. Again, because you're not dividing by 1. Now here, I want you to go ahead and pause and see if you can do this one on your own. I'm going to continue solving it, so then unpause when you're done to see if you did it right. I have a coordinate, negative 3, 3. Give myself a scale. So my coordinate is here, and it's saying I have an angle in standard position. Go ahead and goes to the terminal. Doesn't matter how long that ray goes. And we're using this angle to figure out these 6 trig functions, but I use the reference angle to help me figure it out. Excuse me. So this value from here to here is negative 3. And this value is 3. And I don't know my hypotenuse. Oops, don't give me a square. It's not a square yet. It's just r. So negative 3 squared plus 3 squared equals r squared. 9 plus 9 equals r squared. 18. Got to take the square root. I'm going to put the variable on the left. So this is 9 times 2. So this is going to be 3 root 2. Now look, because of Pythagorean theorem, there's no way your r can be negative because it's squaring everything. It will never happen. So now I'm finding the 6 trig functions. I feel like my handwriting is getting a little bit better with this thing. So, sine, opposite over, let me just put the hypotenuse there actually. Hypotenuse. Can't do that. And I got to reduce it, so I get 1 over root 2, but then I rationalize it, so I get root 2 over 2. Cosine of theta, adjacent over hypotenuse. Reduce those 3's, and then I got to rationalize it to save me a little bit of space. So I'm going to rationalize it right away. Tangent of theta is opposite over adjacent. Well, that just gives me -1. Cosecant of theta, I'm going to flip this guy because it makes my life easier, so it's root 2. Secant of theta, I'm going to flip this guy, so it's -root 2. Cotangent of theta, I'm going to flip -1, so it's -1. Some of us, hopefully, maybe one of you guys, noticed this is a special right triangle because these lengths are the same. So you're in a 45, 45, 90 triangle. So then we know, because we're in quadrant 2, our angle is 3 pi over 4, or 135, that is. So knowing that, and that's just because this is a special right triangle. Up here, it wasn't. So I could just put that new formula to use. X equals my r, which is 3 root 2, cosine of 3 pi over 4. Well, looking at my unit circle, and this problem did not ask us to do this. I'm just showing you that formula one more time. Cosine of 3 pi over 4 is negative root 2 over 2, just looking at my unit circle. So I end up getting -3 root 2 times -root 2, or I already took care of the negative, so root 2 times root 2 is 2, and then I'm dividing by 2, those reduce out, and we do get our x value. And then I could do the same for y. And if you do it, we will end up getting +3. Now, one huge thing to take away, this is not on the unit circle, so I could not assume my x value is cosine and my y value is sine. Whereas going back up to our first example, going, they're blank because I'm only working on that one thing, but this, they told us was the unit circle, so then we could assume this is cosine and this is sine. Huge takeaway. Okay, see you next time.